Hello and welcome to this tutorial question where we are going to deal with two-dimensional motion um, before we have the quiz next week. And so this is a Unit 3 review question, and this is dealing with two-dimensional kinematics, okay, where things are moving in the horizontal plane and in the vertical plane. So here's our question, and it's a doozy. Okay, it's not an easy one. The question is, we have an archer and he shoots an arrow and it hits the ground at a velocity of 53.8 meters per second, and it's coming down at an angle still. So the angle is 73.8 degrees south of east. We'll have to think about what that means. And the question is, what was its original velocity? So what is the question asking for? That's where you always need to start. So on the quiz, on a test, you always need to start with, what is this thing asking for? And in this case, we are looking for this, that original initial velocity. Okay, now what is the symbol or letter that represents that? That's the next thing, because you need to have a formula that's going to solve this for you. So this is V initial, okay, and that is going to be in meters per second, and it is up at an angle, so it's some degrees north of east. Okay, so that's what we're looking for. How do we find this? How do we do that? Now, all of these questions tend to be pretty similar. Okay, we've got an x component, we've got a y component, and they don't affect each other. Okay, the x is going to be staying the same the entire time. Okay, so it's moving this way at the same rate the entire time. The y velocity is changing. Here it's going up. Here it has a y velocity of 0. And here it's becoming more and more and more and more negative. Okay, so how are we going to find the original velocity, the initial velocity? Well, if we know v naught x and v naught y, then we can find v naught using Pythagoras. And if we know v naught x and v naught y, we can also find theta. Okay, so how do we find v naught x and v naught y? Okay, so the way my brain works is I start with, what is this question asking for? It's asking for v naught. Okay, how do I find that? Well, the only way to find v naught is to know the x and the y components. Okay, so now, how do I find those? Well, I do have this information here. Okay, so what does that look like down here? Okay, this thing, the arrow is coming down, it hits the ground at 53.8 meters per second. Okay, so it has an x component to that and a y component to that, and it is coming down at an angle of 73.8 degrees south of east. So here's east, and we go south of east. Okay, so you need to be able to, kind of work out the various components in a question like this as well. Pretty much every question, you're going to have to be able to do that. Okay, now I could have drawn this final velocity up here. That's fine. And again, I'd have v final x and v final y, and the angle would be here. That doesn't matter, but what is important is that we draw a triangle like that. Okay, how do we find v final x? Well, we have an angle, and cos of that angle is going to be adjacent over the hypotenuse. So v final x over v final. And if I multiply v final up here, I'll be left with v final x. Okay, and v final is 53.8 meters per second. So 53.8 times cos 73.8, that gives me V final in the x, and that's just over 15 meters per second. Okay, and that's I hat because it's horizontal, and it is, I'm going to leave it as positive because it's moving to the right. Okay, what about V final y? Well, for that we're going to use sine because we've got our angle here, and sine of that is going to be opposite over hypotenuse. And to get V final y, I can multiply V final up to here. So I get 53.8 times 73.8, and I get 51.6638. Okay, and that is j hat. But now I have to think, okay, hang on, it is going down. So I'm going to make that negative. I can just do that because negatives in physics just tell us, or at least in kinematics like this, just tell us direction. So negative is down. Okay. So here we have some information. We've just figured out V final x and V final y. Knowing these, how can we find V naught x and V naught y? Right up here. Well, V final x is going to be the same as V initial x because they don't change, right? So V naught x is the same as V final x because it's not accelerating horizontally. It's only accelerating vertically. So V naught x, we've already figured that out. Now we need to find V naught y. Okay, that's going to be a little bit more tricky because there's acceleration. So we need a formula that will give us, that has V naught y in it and has an acceleration in it. Okay, so how do we find it? Well, it's a good idea to look at what information we have. So we know our initial position, right? D is position. Our initial position in the y is 120 meters up. Okay, 120 meters j hat. Final position in the y is 0, right? Because it's on the ground. Delta D is always final minus initial. So 0 minus 120, so it's negative 120. Acceleration is negative 9.81. And V final y is negative 51.6. And there are some more decimals. So knowing this information, what formula can we use to find V naught y? Okay, well, we can use this formula. V final squared equals V initial squared plus 2a delta D. We know delta D is negative 120. We know acceleration. We know V final, and so we can find V initial. So we're going to use that formula. I've added y's here so that reminds me, only put y information, don't put any x information in there. And we want to rearrange this to solve for V initial. Okay, so what am I going to get rid of? This exponent or these things that are being added to V initial? Well, we follow SAMDEB, and SAMDEB is subtract, add, multiply, divide, exponent, brackets. So the things that are being added, we're going to get rid of those first by subtracting them. And then to get rid of the exponent, the square, we can take the square root. Okay, so it's V final squared minus 2a delta D. That would give me V initial squared, but I take the square root of both sides and I'm left with that. So I did that all in one step. If that's complicated, try it on your own in a couple steps. And now I'm going to put the numbers in. Okay, so we've got V final, we've squared it, minus 2a delta D. Take the square root of it, and you can't see that unfortunately. That is, it's showing up below the screen. 17.74. Okay, so how do we find V initial? Okay, we know V naught x and we know V naught y. Well, we can use Pythagoras. Okay, so we're going to use Pythagoras because we've got a right triangle here and we're going to square both of those and then take the square root of their sum. Okay, so v naught x squared plus v naught y squared, and we get 23.23, and there are more decimals, meters per second. Okay, how do we find theta? Right, we want the angle as well. Well, we've got these sides, we've got the opposite side and the adjacent side, so we can use tan, and so we can use arctan of the opposite over the adjacent, and that gives us 49.767, etc. Okay, so we've got our answer here. We just need it in the proper number of sig figs. Okay, so from our data, we've got 53.8, we've got 73.8, and we've got 120. So this has the fewest number of sig figs, 120. That's actually 2 sig figs. So we want our velocity and the angle to have 2 sig figs. So it was 23.23 and then 49.767. So our velocity is just going to be 23. This would be 50, but 50 has just 1 sig fig. So 50 we turn into 5.0 times 10 to the 1 degree north of east. And that's our final answer. So there were a lot of steps here, but the process is kind of the same every time. The process is really, you know, what is it asking for? How am I going to get there? What do I know? And then go from there. So I'm hoping that was helpful, and I'm hoping that you feel a little bit more confident with this material. You're going to do great. Take care.